Okay, we're back. We're going over this as part 3 of site inspection and building assessment. So when you're doing an in-process inspection, or you're going out to take a look at a job, this is what you want to look at on site. These are the types of things you want to look for. So we stopped in ductworks, and we're in ductwork, and we're up to mobile home ducts. So one of the things that we want to do is either get a picture, put your camera down in there with the flash going, take a few pictures and make some adjustments, point it a different way until you get a good shot down the ductwork, or you can put a flashlight down in the duct and put a mirror down in and take a look at it that way. The photo on the right shows a repaired duct that's sealed up with mastic during weatherization. It looks like they've got the mastic a little thin at the top. That intersection between the floor and the duct itself, the boot, should be very well done. This looks like it's a little thin and missing in a couple of spots. Not a bad first effort, but for somebody that's experienced, that's not really good enough. Down here we've got a squeegee, all kinds of stuff down in this ductwork. Who knows what it is? This is one of the reasons you don't want to stick your hands down in there. You may find somebody's kit. You know, you may have an IV drug user or something that is storing their stuff in there or hiding. So be careful when you go in, putting your hand down in there. There we go. Okay. So in the distribution system, and we're talking about the ductwork and the return system. On mobile homes, you can have what's called a belly return. And a belly return is where they didn't put in a ductwork system for the return air going back to the furnace. They simply cut holes in the floor framing to allow air to move through the floor framing back into the furnace closet. So we need to seal that up because it pulls in a lot of outside air and a lot of contaminants, a lot of pollution and dirt with it. So we want to seal those off and kill them. We call it a cold air return system. We're going to kill the cold air return system or abandon it in place by covering it up. Here on the bottom left hand corner, this is a grill or a register that was covering a cold air return opening in the floor, and we've come in and we've blocked that off. Okay. The rule of thumb, and I hate rules of thumb, is about 2 square inches of net free area per 1,000 BTUs of furnace input. Now, this looks like a fairly good job, except somebody that ordered this grill right here did not understand how to order it. When you order a grill, a register, whichever dimension you give first is going to be your width, and then your second dimension is going to be your height. So here they probably ordered an 18 by 24, and what they wanted was a 24/18. Or what they ordered was a 24/18, and what they wanted was an 18/24. This determines which way those vanes, or the little openings on the register, are going to sit. They could have sat horizontally. Here they're sitting vertically, so as you walk down the hall you can look right into the grill. From an aesthetics point of view, that's not a great deal. Okay, the client may not like that. The other thing that we need to be sure is that we have enough combustion air going into the closet, into the closet itself, if we have a need for combustion air. So we may have been covering off part of combustion air coming in. Why they would do it that way, I don't know, but don't ever ask me why mobile home manufacturers have done what they've done. I've never understood it. However, they have done a lot of different things. So sometimes you will see some new things and you have to ask yourself, why is that done that way? Where am I getting my combustion air? Where am I getting my return air for this unit? Okay, so as you move along, you want to note the appropriateness of each installed measure. Take a look at the back of this door. This looks like some pretty poor workmanship on the back of this door. Somebody did not pre-cut the this hollow core door before it was cut to put a grill on it. Now if we're putting a register on the other side, that's fine, but is that hole too small for the register? Is it the proper size? Because just because the register has enough net free area doesn't mean that we have that free space in the door itself. Be sure we've done a good job there as well. Okay. All right, a setback thermostat. You want to make sure that we install a good Energy Star rated or qualified programmable thermostat on it. Now, what kind of things should you do with the client when you put in a new thermostat? I know a lot of you are going, oh, I know this one. Yeah, client education. You've got to teach them how to use this thing. This is probably one of the most challenging things that we do. I do not understand why thermostats have to be the way they are, even these programmable setback thingies. Why we use little buttons, why we use little displays. You know, it was so simple. The old circular type, that's what older folks have grown up with. That's what they're accustomed to. It's got 2 levers on it: turn the fan off, turn the fan on, turn the fan off, put it on, you know, hot or cold, you know, heat or cool, and then make the temperature warmer or make the temperature cooler. That's very simple for them to understand. So you've got a big challenge here. We have all those same functions on this newer thermostat. They just don't look the same. All right. They don't look the same at all. So we've got to try and educate our older clients on how to read these things, how to understand them. Sometimes if you've got a little giveaway flashlight, battery-powered flashlight, donating one to the cause and leaving it by that thermostat is, you know, it's a priceless gesture for somebody with older eyes, because now they can pick that flashlight up and they've got enough light on that thermostat to see what all these little words are. Because I mean, even for good young eyes, these are some small words. The other thing is, go over the instruction manual with them and maybe make some marks in there that shows how to override the thermostat temporarily, how to reset the temperatures on them if the set points are not comfortable for them. Teach them how to use that thermostat, but then encourage them just to leave it alone and try it for a few days before they decide to start messing with it. When we get into the basement or other subspaces, you know, below the house, we need to look at a few things. We may have combustion appliances or other appliances down in the basement. So what are we looking for? We're looking for, well, how about a water heater? What's the set point on the water heater? Is it recommended? Is it within that range? Did we test the output? Do we have insulation on it? And are the hot and cold water lines insulated? Okay. What about on the furnace? Do we have enough combustion air coming into it? Has it been tested? Is the flue in good shape? Have we run combustion, worst case combustion appliance testing on that? The foundation walls, do we have cracks or leaks? Are we going to have water infiltration coming through? Do we have air infiltration coming through? Right around the band joist and the mud sill, have we insulated properly where we need to? Is that work acceptable? How about bypasses through the floor where we may have penetrations like around these pipes? Have those been sealed? Okay. Do we have well, our duct work for the dryer, is that properly terminated? Is the material that the dryer duct is running through, is that proper? This door here is probably now considered an exterior door. Was it insulated and weather stripped and air sealed? Okay, these are all things that we need to look at. And then stop and ask yourself, is this basement conditioned or unconditioned? If it's used and it looks like it's used and it looks like a family lives in it because it's got furniture and decorations and televisions and entertainment stuff, yeah, that's a conditioned basement. If it looks like nothing more than storage and has appliances down in it, then no, it's probably not conditioned. Okay. Alrighty, so when we're looking at a conditioned or an unconditioned basement, one of the things that we look for is it reasonable for it to be conditioned? And these are just some guidelines to help you decide whether or not it should have been in the first place or not. So if more than 50% of it is below grade, it has a relatively tight or unvented foundation, it's used as a living space, and it's either intentionally or unintentionally conditioned. However, it probably should be unconditioned if it's less than 50% below grade, it's leaky or vented, or it's severely degraded, has a severely degraded foundation, it's not a living space, and it's not intentionally conditioned. Sometimes a washer and dryer down there tells you there is some limited use, but it could, and that may qualify it as a conditioned space. Really, this is one of those things you've got to talk to the client about. How much time do they spend down there? How comfortable do they need to be down there? And are there other things that we can do to protect water lines that are down there? Remember, just insulating water lines in a basement sometimes is not enough if you've got enough exposed wall. In other words, you don't have enough of your, excuse me. Wow, it's the hay fever season in Little Rock, so I'm kind of sneezy. If you don't have enough ground insulated wall, you may have a lot of exposed wall on that. So you may, if you remember, insulation just prevents the transfer of heat. It doesn't put heat into anything. If those water lines are not getting heat from somewhere, then eventually they're going to get down below freezing and break. So does that basement ever get down below freezing? And if it does it need to be an unintentionally conditioned space so that we keep that temperature above freezing? All right. What can we do for an unconditioned basement? Well, typically what we're going to do is air seal all of our bypasses between the basement and the house. We want to, if we have ductwork down there, we want to seal it all, okay, because now we're going to consider that basement outside. We want to insulate all of that ductwork because, again, we're going to consider this outside. We don't need to insulate ductwork that runs to the inside of the house. We're going to insulate the floor if that's appropriate and that was called for. And we're going to insulate closed floor cavities as well. So if we have areas that are panned for some reason with sheetrock, and I'm not talking about panned for ductwork, I'm talking about just partially finished, we need to insulate those areas as well. Okay, in a conditioned basement, we want to move our air barrier to the outside. Instead of being up at the floor level or the ceiling of the basement, we're now going to push it to the outside. That's where our thermal barrier is going to go as well. So we want to air seal the perimeter, especially the mud seal and the band joist, and all of your air pathways between the basement and the house. Okay, we want to seal off any part of that basement that's unconditioned. We may have some utility rooms or storage areas that are rooms off of the basement that we want to seal up. Okay, coal bins, unvented crawl spaces, you name it. Seal the return plenum in any of your ducts that are down there for safety, because if you have combustion equipment, you still want to seal this stuff because you do not want to depressurize that basement with your ductwork. Okay, remember, ductwork can either pressurize or depressurize an area depending on when and where it's leaking. You want to mechanically refasten any boots to register transitions and repair any broken trunk lines and branch ducts in your ductwork. And then insulate the band joist to the recommended R value with polystyrene board or two-part foam. You can use regular insulation, but it's going to have to be pretty thick stuff, and trying to get it up in those areas and getting it to stay is very difficult. That's why we're recommending foam board or a spray foam. And then consider insulating above grade basement walls with two-part foam or bad insulation that's been wrapped in a vapor barrier in order to keep that above grade portion more temperate. In other words, keep the cold out, because especially in northern climes, those areas will be a lot colder than the subsurface portions of the foundation. The ground doesn't get quite as cold in many places, many parts of the country, as exposed places, nor does it stay cold for as long if it does get cold. Okay, North Dakota, you guys are on your own. All right, that's crazy. Y'all are just crazy. You know what I think of y'all. You're crazy people, but I love every one of you. Okay, unconditioned crawl space options. If we have a crawl space, then what we're looking to find out or to see is that we have any moisture issues have been resolved. That if we needed to do perimeter mud seal and band joist sealing, then we have done that. And air pathways between the house, remember, seal high, and then come back and seal low. So now we're sealing low. We want the area between the basement or the crawl and the house done. We want a ground vapor retarder put in minimum of 6 inches of overlap. Now, anytime you have a ground vapor retarder, 6 to 12 inches of overlap and sealed up. Should be sealed with tuck tape or construction tape. We want our foundation vents sealed. Okay, that is a very controversial thing. However, what good does it do to try and air seal this area and then ventilate it? If we don't need it sealed or vented, then let's vent it. Remember, venting is to get rid of moisture. If we've resolved the moisture issues, we don't need the venting. Check with your codes, though. Your codes may not allow you to seal those foundation vents. Any ductwork down there, because it is on the outside now, it's not in the conditioned space, needs to be insulated, and it also needs to be sealed. Your floor joists, if you're insulating, probably from about zone 4 down, we will not insulate floors. From about zone 4 up, we will insulate floors. It all depends on what your SIR is and what your audit is calling for, and also if you're working under a priority list, what your priority list calls for. Your floor is now going to become your pressure and your thermal boundary. Okay, so here we're pulling our pressure and thermal boundary up to the floor. This next slide, we're going to talk about moving it to the outside. If this is a conditioned crawl space, then again, we want to resolve any moisture issues and put down a ground vapor barrier. We want to seal off the foundation vents for sure, okay, because now we're going to condition this area. Again, we want to go around the band joist and any of the foundation issues and seal those off, okay. All of our air bypasses between the house and the floor, we still want to seal those. We don't want to bring air from this area. Even though it's now conditioned, it's going to be indirectly conditioned. We're not going to directly condition it. Ducts that run through here can be left uninsulated, but however, the returns in the supply should be sealed. Okay, so we should seal the ductwork, but we don't have to insulate it because it's going to be so close to the house temperature through indirect conditioning, it's not important. But the foundation walls, the exterior walls, should be insulated. Okay. So down in this area, we need to think about air sealing. On the left here, we have an unsealed plumbing penetration. That should have been covered. Okay, here on the right, we have a sealed plumbing penetration. Again, I'm going to warn you about using foam and foam board, foam products that are exposed to the conditioned space. Remember, there are very specific rules about exposing that. You're going to have to cover them in sheetrock anyway. Why not use a different material that has a flame spread rating of 25 or less, where you don't need that, or has a lower ignition temperature where you don't need that. If you are going to use it, then you use a code approved foam board, and I believe Thermax is a brand that may be exposed under most codes. That's Thermax, T-H-E-R-M-A-X, I believe. So here we're looking for air leakage issues. We have a basement stairwell that we're looking at. The basement stairwell does not have a landing on it. You know, it's a heck of a first step, but here this basement stairwell has all of the has foam board put up, insulation around it, and it looks like it was air sealed. Here on the right hand side, we've got a mobile home belly that they tried to, I don't know what they tried to do. That looks like foam all over the place, but my goodness, that should have been done with a proper belly repair material. And it's really poor workmanship, misuse of a product that is not the right product for the job, not the right material. Here on the left, we've got above grade penetrations. So we've got a perimeter that we need to seal. This is going to be in your subspace foundation area. Did we insulate it? Did we seal it? So here's the mud sill and the band joist, and you can see that they come back and sprayed with 2-part foam as an air sealant. Okay. Here on the left, we've got a mobile home belly where the insulation has just collapsed. It's fallen. It's been left untreated. The photo on the right is a crawl space, and what I want to know is this crawl space conditioned or unconditioned? What do you think? Take a look at that picture. Would you say that that's a conditioned or an unconditioned crawl space? I'm going to say it's unconditioned because we have, although a poorly done job, we have water pipes that are insulated and we have ductwork that's insulated. Okay, so I would say that that is an unconditioned crawl space. Okay, we're still down in the crawl space. We've got two-part foam on the above grade portion. On the above grade portion of a foundation wall. It looks like we also have a dryer vent that's running out there. Okay. We're looking for clues here to determine whether or not this subspace is conditioned or not. We see a lot of stuff that tells us, look at all the cobwebs there, that tells us we've not only had a lot of air movement, but that we probably have not been conditioned living down in here because of the cobwebs. Doesn't look like it's been cleaned in a long time. The two-part foam is pretty well done. Here on the right we have a light commercial building insulation that has been installed on the basement walls. The vinyl phase fiberglass is moisture tolerant. It's been installed exceptionally well here. They've done a really good job here. I will tell you though, if you have cats, they love that stuff. They're going to tear this up. You need to make sure to keep cats out of there. All right. So what about a ground vapor retarder or a ground moisture barrier? Was it installed, and is it installed properly? Here on the right, this is never going to fly down in our part of the country because the termite inspectors would just have a conniption fit. We need to leave an area bare at least 6 inches for them to take a look at and do termite tunnel inspections. Otherwise, they're just going to say, nope, you don't have any more termite insurance. So over here on the right, the ground moisture barrier is put down, and then they've overlapped it with that insulation, and they've got 100% coverage. Although here on the left-hand picture, it looks like we don't have good sealing around these blocks. So good try, good job, but it could have been better. Here on the left, or here in this picture, we're looking where the basement wall and the foundation come together. And here we're seeing that we're only partially sealing this. We don't have good coverage with our sealant. So have we done a good job here? Well, this is a situation where the work was done, but it was either not, you can either call this incomplete. I wouldn't call it incomplete. I would say that it's substandard because we did not finish air sealing. We don't have a good air seal there. And now the only way to prove that you don't have a good air seal, again, don't just visually inspect it and go, this is a problem. Okay, get your smoke and your blower door running and make sure, because that's the way they may have air sealed, is blower door guided air sealing. And just because it looks like it should leak doesn't mean it truly is leaking. Okay, so be sure that you don't have any air movement there before you fuss about there being air movement there. If there's enough room to insulate the floor, there's enough room to install a ground vapor barrier. If they're required by your local field guide, then there's no valid reason in the file not to install one. Then this is a case where we're going to have to send the weatherization folks back out to do a better job here. Take a look at the floor insulation. This is a really poorly done job of floor insulation. Your report should show this. Okay, should show pictures of this, the missing ground vapor barrier. If you have a priority list or a field guide or other requirements that require a ground moisture barrier, unless there's a reason not to put it down, then you need to reflect that in your report that this is substandard work. Okay. If there were health and safety repairs made, did we document them properly? So we have a crimped up, balled up, wadded up, whatever you want to call it, vinyl dryer vent that doesn't meet the UL listings for use on a dryer. It's way too long. We've got an elbow, metal elbow here, so that should be replaced. Okay, other dryer vents what are some other subspace repairs that may be allowable under health and safety? Okay, stop and think about that. We're talking about subspaces right now, which is going to be crawl and basement. What other kinds of things? Well, we're allowed to do, believe it or not, sump pump repairs, water pump repairs, and dehumidifiers, okay, as health and safety. Refer to your dryer vent section on the installer intermediate curriculum for more details on the exhaust or on the dryer exhaust protocols. That's a good reference. What they're talking about there is in the DOE standardized curriculum in their installer intermediate portion. They have a section on some dryer vent protocols. I will say always put it in hard metal vent when you can, but it has to be in a rigid metal vent according to our code. Okay. So window replacement. If we had window replacement, was it really done? Window replacement is getting harder and harder to pull up as an SIR in most places. Here in Arkansas, we can still get it fairly well in a lot of instances, but you got really bad windows on the left, and probably should be replaced. The unit on the right is a combination unit with a U factor of 0.20, and it was used to replace a fixed unit of multiple single pane windows. So we've taken out single panes and added some double panes in there. We have brought this up to a better insulating value. The trouble is you're bringing it up from an R1 to an R2 or an R2 point something, maybe an R3. You're not gaining a lot. A lot of times money is better spent elsewhere. The point is, you can in some cases get an SIR when you've got a big enough area such as this, but you need to check what the audit called for and then check workmanship. Was it done? Did it need to be done? Is it a missed opportunity? On the left, this really looks like a missed opportunity. Okay. If you have storm windows installed as an alternative to primary window replacement, then some of the things that you need to think about is, do we have weep holes in them? Are they installed properly? If they're permanently installed, are they self-storing storm windows, meaning do they raise up so that the client can still open it? Otherwise, they're going to pull those windows off and never put them back on. A lot of times storm windows are a good thing, but not all the time. Can you think of a time when you should not see storm windows? Stop and think about it. If you're going out and looking at a job, when would you expect not to see storm windows? Well, that's almost a trick question. It's not quite, but how about if the audit didn't call for storm windows? And how about if it called for window replacement instead? Okay. We want to make sure we're getting what we pay for. Replacement doors. Doors are getting more and more difficult to replace, simply because a lot of repairs can be made to them, and most of the time a few adjustments can put them back in a serviceable condition. The door on the left probably qualifies as a replacement door. Okay, the door in the middle, that's a good Energy Star door. However, when it was modeled, we should take into account that window right there. That window should be modeled differently. Same thing here on this door. If we're modeling it trying to get an SIR, we need to be honest in the audit and say, you know, we've got this much door, so effectively this much of this center door is good steel insulated door. From there up, it's something less. It's going to perform at something less, especially for that half moon light in it. Window. So here we've got a really good job of replacing a sliding glass or a double wide unit, okay, a double width door unit, a sliding glass window unit with a combination window door replacement. They did a very good job integrating this in. They've made it look pretty darn good. I would say that this is a very good example of good quality craftsmanship at work, okay, and a very good solution to a tough problem. How do you replace a big sliding glass door effectively? Weather stripping, thresholds, sweeps, all of these are important. You should check them, make sure the latches are in good shape, that the door seals easily. Excuse me, I guess it's getting close to lunch. Are thresholds installed where they need to be? Here in the center picture we have weather stripping that's not properly secured. It may be a vinyl and it was installed when it's cold and there wasn't enough expansion room, so now it's buckling up. If you've got basement doors or bulkheads, those should also be insulated if they're going down into a conditioned basement, as well as have some kind of weather stripping on them. Remember, you've got to treat those like an insulate or like an exterior door. Okay, sunscreens and films. We don't see a lot of sunscreen application or film application here in Arkansas, but the DOE does allow sunscreens and films. Your southwest and east facing windows, if they're not shaded during the summer months, are generally going to get these films or screens. When a solar gain overheats a room, it causes a higher AC use. However, we have a treatment here, and here in Arkansas we're not allowed to put on awnings, but let's just assume that we were for a minute. Here we have an awning that was put on, yet this, if you look, this window is already shaded quite significantly by a tree. Why would you add more shading onto it? The only reason is that the auditor did not call out how much shading it was getting during the day. He estimated that wrong. Even 10 or 15% shading of the day is probably going to cause this to fall off. Pardon me just 1 minute here. Goodness, pardon me. Okay, so window film guidelines. If you're going to put on a window film, it has to have a shading coefficient of 0.4 or lower. It has to have a U factor of 1 or lower, and the total solar energy rejected has to be at least 65%. The film has to be approved by the manufacturer for use on insulated insulated glass and insulated panels. Sometimes these things have a low E coating on them, and they can cause some really serious problems on double pane or insulated windows. Okay, on water heater replacements, well, first of all, what might justify a water heater replacement? Generally, one that is non-functioning. We've got it leaking or severely corroded. We have a tank that's clogged by mineral deposits. It's inoperable or only partially operable, or it has unsafe operating conditions. It's been damaged by flame rollout or high CO production. Well, high CO production in itself is not going to do it, but you get the idea. These are the reasons that we can replace one. This tank on the left is installed outside. It's in a temperate, very temperate climate. However, it's being exposed to rain, or it's been leaking pretty severely because we can see a lot of rust. However, I think that this is a rainwater issue, not a leaking issue. As a plumber, I'm going to look at the bottom. Down here, we don't see a lot of rust at the bottom, which is typically where you would see it. You would have a leaking tank and water would build up, overrun right there, taking a lot of rust out of it. Up here on the top, however, we are seeing a lot of rust, which makes me think that we've got rainwater coming off of it. Although it's coming out pretty strong right here in this area, so it may be a tank leak. Okay. The one on the right has strapping on it for hurricane or seismic zones. You'd be surprised how many areas are in seismic zones. Now here on the left, we've got a pretty good job of tank wrapping. Okay, I would be careful. This is looking like it's coming just a little bit too high to be on a combustion appliance. Notice we've got a draft diverter on this, so this is getting above it. We do not want to put any insulation on the top of this thing. And the other issue is, do we have good air going into it, good combustion air still going into it with our wrap? Here on the right, oh boy, this is a fail. This is really bad. The tank wrap has fallen off. It wasn't secured properly. It's sagging, not good. That's one we'd call for rework. Pipe insulation here on the left. This is a really poor job on the left-hand picture. Over here on the right-hand picture, don't forget that we need to have clearance to combustibles. It should be on a single wall vent, minimum of 6 inches clearance to combustibles. This is why these things are just so degraded. It doesn't look like they secured it with any tape. They did not continue with the same thickness around the valve area. This is something that calls for immediate action. We've either got to take this water heater out of service, or we've got to remove this foam, because this is a fire hazard. Okay, not a good thing. Something has to be done about that right away. Okay. Here on the left, we've got a water heater with burn marks on it, which indicates that we've had rollout. That's a safety issue. Here on the right-hand side, we're showing a lot of rust from spillage, either because we've got backdrafting causing spillage or an insufficient draft causing spillage. And we probably have a lot of rust or discoloration up here. What I do see, however, is that we've got a water heater going into an old cook stove pipe connection, and this is an improper connection. We're running downhill with this. This is not right. Let's see if I can make a better arrow for you. It's running downhill. Okay, that's just completely not right. Let's move on here. Lighting. CFL should be installed by the agency and not left for the client to install. You want to think about your base loads. We have certain rules for, or different states have different rules for treating base loads. Some of them have a requirement change as many bulbs as you can. Some programs have a requirement change as many bulbs as you can. Others require some basis in Optimizer or other software for changing them out based on wattage consumed and number of hours used per day. In other words, power consumption, to change them out. However, the biggest point here is that when you're counting bulbs as an inspector, you're looking to see what they were installed in and whether those lamps are the proper lamps or fixtures they should have been installed in. If they're being installed in closets, question that. Question that quite a bit. Why are they installing them in closets? Does somebody really use that closet for 2 or 3 hours a day? Which is generally what the minimum requirement is, 2 hours use a day. If you're seeing them replaced in reading lights and in kitchens and in hallways or bathrooms, yeah, that's probably a good use of them. Refrigerator replacement can be considered if it meets the DOE requirements for replacement, and that's all specified in a WPN. But basically, you've got to meter the refrigerator, or it has to be on an approved list of refrigerators that have a known energy usage for them. And traditionally, only one refrigerator per home. And they have to be, the old ones have to be removed and decommissioned. We talked about that in another section. But when you're looking at refrigerators, be sure that the new unit is what it is supposed to be, that it fits. I can't tell you how embarrassing it is for an auditor to get out there and have mismeasured the area that the refrigerator is going into, and they've gotten one that will not fit. And they, you know, the people that bring it out, they don't care whether it fits or not as long as they deliver it, usually. In some cases they do care very much, but my point is that it should fit. So if we've got the wrong refrigerator there, we've got to do something about it. Okay, smoke detectors, CO detectors. When we have combustion appliances, we need one CO detector should be on every floor level of the house. That's conditioned space only. And smoke and CO detectors are health and safety measures. Take a look at the smoke detector. Okay, here's the top of a doorway. Do you see anything wrong with where that smoke detector is installed? Okay. Normally, they are to be no more than 6 inches from the ceiling. So as an inspector, I would want to see the manufacturer's instructions on that and be sure that that is the location that the manufacturer was calling for that smoke detector. If it's not, then that needs to be corrected as a health and safety issue. Okay, even if it were pre-existing, it still needs to be corrected as a health and safety issue because it's not installed properly. Okay. All right, other health and safety issues. We're going to talk about moisture and mold a little bit. When you're taking a look at the home, is there evidence of mold-like growths in the home? Was it noted in the file, or was it caused by weatherization work? These are very important questions to ask yourself. When you see damaged ceilings and mold growing in it, especially like on the left there, we want to know whether that moisture condition was corrected. On the right-hand side, we've got a very severe mold issue. This should have been resolved prior to any weatherization work taking place in this home. All of this should have been corrected before we even came in to do any work. We do not have money to mitigate mold. All we can do is clean up to 10 square feet. That's it. After that, we can't help them. Okay. Cook stove testing. Cook stoves are notorious for producing CO. They're allowed to produce up to 800 parts per million brand new out of the box. That is a tremendous amount of CO, but that's what they're allowed. So we're looking for something much lower, much safer. We test cook stoves because it's not uncommon for them to produce CO. They're used quite a bit as heat sources. It's not uncommon for somebody to get up early in the morning and go sit in the kitchen drinking coffee in front and have the oven on or a couple of burners on rather than kicking the central furnace on. Maybe they set it back overnight. The other issue is that CO kills, and that when you know these things going in as an inspector or as an auditor, that knowledge implies action. So if you go in and you don't test a cook stove knowing all of these things, then you could be liable if anybody is hurt because of or injured because of CO production from that stove that wasn't tested. Okay, you ignored a potentially dangerous problem is what the implication there. So some of the corrective actions that we can do for this is we can repair, clean, or add additional mechanical ventilation. Our stove test should be documented in the client file. And more on this is covered under combustion testing, although we're not going to get too deeply into it in this. You should have already had some pretty rigorous combustion testing. Now some of you are going to have some combustion testing, and we'll get into it very deeply with you. However, understand that what we're going to be looking at are BPI standards on combustion testing. Okay, so heads up for you. The stove on the left was producing about 72 parts per million, and for the pre and post weatherization blower door tests showed a house-wide reduction of 4178 CFM down to about 1978 CFM. So that's quite a bit, 2200 CFM. So we've lowered the dilution rate, which can cause much higher ambient CO after we're done. Okay, so here an exhaust fan or the installation of an operable exhaust fan should take place. Okay, now the photo on the right shows a new exhaust fan. You can see that aesthetically it's not the most beautiful thing in the world, but it works and the client accepted it, and it is vented to the outside. Okay, a lot of kitchens are served with a recirculating vent fan, and the one on the left is one. See the vent openings in the front? This is probably a recirculating vent fan, which means that 72 parts per million is not going to become diluted or is going to be removed. It's going to be recirculated in the house, so that is going to keep going up and up and up as long as that stove is in use. Okay, here we have a completely non-functional bath fan on the left. It looks like somebody has taped the grill up to it. Bathrooms are typically high moisture areas, and fans are put in to deal with that moisture. They're not really odor control devices as everybody wants to think of them. They're really moisture control devices. When we tighten up a house, we're lowering the dilution rate. We're lowering the amount of air that gets mixed with that moisture. So moisture concentrations can go up, pollutant concentrations can go up, etc. Sometimes we add mechanical ventilation in order to deal with this. Here on the right hand side, we're seeing a horizontally mounted, in other words, a wall mount bath fan that was installed to add additional mechanical ventilation to this bathroom. The only comment that I have is that it doesn't look like the duct is completely sealed on it. I would like to see the addition of some duct sealant on that, but that all depends on what my field guide and what my standard work specifications or any other standard that I'm measuring or inspecting this home to. This may be perfectly acceptable per code, but it may not be acceptable per the field guide. Okay, what are your standards for your program? That's what you have to continually ask yourself. Just because you would like to see something additional doesn't mean it has to be there. Okay, it should only be there if your standards call for it. So does it meet standards? Was it installed and does it meet standards? Okay, you're not asked to comment beyond that. Okay, worst case combustion safety testing. This is done under worst case conditions. We try and make it as bad as we can, and we should have checked for spillage, we should have checked for draft, and we should have checked for CO combustion. All of this should have been done at the initial audit and at the final inspection, and it should have been done for all vented combustion appliances. Any unsafe appliances should be deactivated until hazards are fixed. What does that mean? That means that you, as a quality control inspector or an auditor, when you find a dangerous piece of equipment, you have an obligation to shut that equipment off and tell the homeowner, do not use it, and why. Okay? Because you found it to be unsafe. Now, if there are conditions which made it that way, then you may not need to shut off the combustion equipment. Who wants to turn off somebody's water heater for the weekend, especially when they have company coming over, when it's really, a particular fan in the house, like in a second master bedroom that's being used for storage. It was that fan in there that caused the problem. So let's just not use that fan. Let's tape it off and put a sign on it that says, hey, don't use this. It causes a problem with the water heater, and we've called somebody to fix it. And then we need to get it repaired very, very quickly. But sometimes, just turning the circuit breaker off for that can save somebody losing hot water for the weekend. So as a technical monitor and inspector, what are you looking for? Well, you need to understand that the air barrier and the thermal barrier, what they are, where they are, how to find them, and how to make sure that they are aligned properly. Okay, so that you should have picked up from this. And then recognize whether the appropriate weatherization, or I keep saying weatherization, recognize whether we have appropriate energy saving measures installed. So if we look at the audit, was the audit reasonable? If we look at the priority list, was the priority list reasonable for this home in light of the home? And then did we have any missed opportunities? Okay, if there were missed opportunities for energy savings, then we need to see about doing something about that. Okay, we may need to write a change order or something. The other thing is we need to evaluate whether the repairs and health and safety measures were justified. Did we make any incidental repairs to protect an energy saving measure, or did we make them just because? Okay, and then judge whether the installed measures meet our standards and our specifications for quality workmanship. If they don't meet that, then we need to call for additional work or rework. Okay, we appreciate it. This was a big bite. I know we've done it in 3 parts. Thanks for persevering. It's a very, very big bite. But this is what it takes to be a quality control inspector out in the field. You have to know quite a bit. You have to look at quite a bit. And it is not for the weak. You've got to be very determined to be fair at all times and objective at all times, but honest with what you see. And sometimes that's a very difficult thing. You want to point and laugh, and the right thing to do is just point and say, this needs to be redone. Save the laughing for a later time, but enjoy it. It's great work. I appreciate it. We'll see you on the next section.